Hello, my name is Janusz and I will try to respond for issue 337, and it is related with georeferencing. So I will just show the proper workflow to show georeferencing. So if you have this issue, please follow the movie. So first I will launch LiDAR odometry. Then I will choose presets like velocity less than 8 km/h for precise forestry application. And then I will choose dataset. So I have chosen dataset. It is quite long. I hope it will converge as AAP. So this is our dataset, our initial point. So we expect that the trajectory will move soon. So as you can see, data were collected correctly. The trajectory starts with 0.000. It will be our first ground control point, and soon I hope the trajectory will move. So let's back a little to our issue. So what we can see, it is a problem with ground control points, and there is a not so clear how we should use the software for this purpose. So there's an example like for each clicker running at least isolate algorithm, different initialization. Okay, there are plenty of depths. So let's back to our data set and let's calculate it properly. So during the calculations we will have also some intermediate results. I will show you. So I'll just delete the previous one. So we have every 100 calculations we have temporary file that we can watch in Cloud Compare. So if you have the data, then the folder preview will be given by program, and we can watch it in Cloud Compare during the calculation. So let's see what we have so far. Looks quite okay. Our calculations are 50%. Oh, what you can see here is that in some distance our colleague placed the Monday system on the ground, and it is a proper placement for the ground control point. And each ground control point is georeference, and I will show you how to apply these numbers to the system. Okay, so let's take a look about our system now, our SUVI. So our SUVI looks like this. This is our expected result. We have some ground control points in each, let's say this curvy trajectory that it is formed when the Manda is placed on the ground. So this is another view. So you can see top view. You have ground control points, and we solve it, this parking for trams with Monday, and then we calculate it. Yeah? So shortly speaking, back to our preview folder. So everything looks fine in 3D. And back to our calculations. We have 27%. So you can see that our trajectory is going from one control point to another. So maybe it is time to show you how we prepare such control points. So I will open some Excel file, and what you can see ground control points numbers here, and you can see ground control point 9 is 0, 0, 0. It means that our origin is here on the bottom right corner, GPC 9. And you can see the all x, y, z coordinates, they are offset with offset according to this GCP. So you can see some big numbers after projection of longitude, latitude to the local coordinate system, and then you offset to 0, 0, 0. So once we have, for example, GCP9, we have GCP9 here, and once you have longitude, latitude, you have to project it into easting and northing, in that case, coordinates, and then using these offsets here and here, you have to transform entire system to 0, 0, 0 by choosing one control point as a beginning of the origin. Hopefully it is clear for you. If not, please send me issue and I will try to explain you how to do that in next movie. Back to our calculations. We have 42%. So we just go around. So basically speaking, this year I decided that that we will work within such a scheme that once you find the software, and then if you would like to apply certain issue with the software, please go to the issue section, then type new issue, tell me, for example, how to convert WGS to local, then I will create a movie for you. And it will be very easy to collect issues and movies for you, so plenty of end users can benefit from it. I will try this year this approach because previously I wrote some documentation that was not so good idea. I make some presentation, also not so good idea. I made plenty of movies that were some useful, but not for all of us. So I hope this approach will help. So the idea is that I will collect issues and I will respond to this issue with a movie. I hope it is sufficient for you. Okay, 51%. Okay, this is calculating. It's more than half. So let's back to our data. Our preview. So you can see some preview. It is 1% of the data that we collect and calculate, and I can see that everything looks very optimistic, so we can continue our calculations. if we make this, you can see walls and you can see structures that they are created from the trajectory that is not affected by any error. So let's back to our calculations. Let's see what we have. Oh, we have 60% and we're going back. So you can see now that we have 1, 2, 3, 4 already ground control points. So I will repeat that every time you go around 20, 30, up to 50 meters, you just place the system on the ground, like here, for example. This is the moment that we are placing the system on the ground. Wait a moment with the system on the ground, so you have a very stable point that can be considered the static one. And in that sense, we can apply later on ground control point to it. You can see that the survey is done perfectly because we place the Monday system on the ground for quite long. It can be 1 minute, it can be 2 minutes, longer better, yeah? But I think 2 minutes is much enough. So let's take a look on our data. I used to check the data set during calculations because I can see from the top if it is sufficient or we have a certain problem. Obviously speaking, you can investigate your system also with another software that it is for inspection. So we have the software, give me a second. Monday Raw Data Viewer. So in this software you can watch all data. One by one. So you can watch all data one by one, so just you can watch it here once you collect the data, and you can easily check if everything is correct looking from the data acquisition point of view. Everything looks quite optimistic. So you can simply move this slice and you can go. You can see that it rotates around, so it means that we have drastic drift of the IMU around that axis. You can see that it is rotating. So this is the tool that you can inspect your data if everything is okay. Back to our calculations, we have 76%. We have another ground control point. You can see 1, 2, 3, 4, 5, 6 control points, and we go back to the first station. So let's wait a little. Obviously speaking, during the wait you can see data, how it is growing. And it looks very nice. One comment: for such scenarios, I suggest that we will use precise forestry parameters. I will try to elaborate a little. So we have parameters, presets, and you have tiny spaces. And please, if you do not have tiny spaces, do not use these parameters. fast motion open spaces, it is quite good if you mount on the bicycle, the system. And this one, velocity less than 8 km per hour, precise forestry, I have to change this name because it is for open spaces, forests, and all the, I can see that this set of parameters is most relevant for most cases. So please use this precise forestry if you have problems with tiny spaces parameters. Okay, so let's back to our calculations. Almost done. 87%, and we have another control point you can see. So it is rather easy survey. So we go back to first station. And we close the loop. It's already 16 minutes. It will be quite long movie, but don't worry, I will show you everything here. So we are going back to the first station. You can see that with these parameters we end up into exact place thanks to the survey within the same map. So this is typical scenario that we are within the same map, so we can localize very accurate in such a scope. Okay, we have to wait another 7%. So what we have to calculate another 200 nodes. This last 150 nodes, 96%, so we can wait a little. Please be patient because it is about, this movie is about helping you in this issue once you would like to georeference data with obviously ground control points. Last 50 nodes to optimize. Okay, now it is saving data. We wait once the software publish result, then we will continue with step second. So almost done. Okay, we have information, and the information is that it is saved in continuous scanning 5 Leo result second. Result second. So let's find this one. Result second is here, so we will use it in step second. So we have another tool that we can georeference data. Where is it? Where is it? Multi-view TLS registration step second. So we will open session. The session is here. Okay, so to show you how to work with this software, then it is essential that you can change color of the background. You can also change color to random of point segments, and then you can also increase the number of points to visualize, so you have everything. But for us, the most significant now is the ground control points. Okay, so we have ground control points. Okay, so where is it? Why I cannot see? Give me a second. Why I cannot see the trajectory? Because the trajectory is black color, so I will change to the white one, and you can see the trajectory here. So maybe I will change color to some gray scale, so much better. Okay, so we have the trajectory, and back to our documentation. So what we need, we have to apply our ground control points that they are here. And we have ground control point 9, 0, 0, 0. Where is it? We can see here ground control point 9, but it is from my previous work, so maybe we'll use this one. Ground control 9 is this one. So we apply it here. Okay, so to apply ground control point, first of all, you have to have ground control points GUI, and it is written to pick trajectory node, please press Ctrl plus left or middle mouse. Okay, so you can see that I am pressing. You make zoom, and you click somewhere in the middle. Okay, it is in the middle, so we can add control point. We can change the name. The name will be GCP9. GCP9, and now we have to apply certain parameters x, y, z. So we have 0, 0, 0, but be careful with the z, because it is not 0, it is the number of centimeters above surface. In our case, it is 35 centimeters. It means the height of the LiDAR center from the ground. Because it has handle, it has to be 35 centimeters. And you can see here, we have this ground control point here. Okay? So we have the first ground control point. Let's find another one. So we have another one, let's say ground control point second. Where is it? Second is in the left top corner. So let's watch left top corner, ground control point second. So again, control and left button again. Okay, we are in the middle, so we can add control point. The default name is GCP second, and our GCP parameters are -55, -55.727, and here we have 8.554, and Z is -0.016. I forgot 0.35 will be different. 0.35 it is here. Sorry, default LiDAR height above ground. Sorry for this inconvenience. 0.635. But here Z it is from this one, and this one is from second. Okay, another control point will be ground control point, let's say 10th. Where is it? 10th is this one, corner top right. So we have top right. Let's find. Okay, it is like this. So it is ground control point at ground control point 10th. So it is ground control point 10th. And we have minus 0.049. And we have here 9.204 and 0031 0031. Okay, we have 3 ground control points. Okay, but we have to check if it is correct or not, because this is quite suspicious situation. So let's find a way how to resolve it. By clicking Tools, Leo Segments Editor, we can take a gizmo for the first one, and we can use this gizmo to manipulate entire system. What you can see here is that I manipulate entire system, and you can see essential drawings from trajectory links to the ground control points. Can you see it? I hope it is visible, those three enough to find the transformation. So you can see that I aligned manually the system to ground control points plus minus 1 meter. Okay, and now I can back to my ground control points GUI, and I can click now register session to ground control points. By clicking this one, it is already aligned. It is already aligned, and we can see some deltas, ground control point deltas. Is around 1 meter. So let's take a look if it is correct or not. Ground control point, this one, it looks very well. It looks very good. And this one looks very good. You can see that the system is placed on the ground, and you can see the distance. It is 35 centimeters, so it looks very good. I think we can simply export data because we have already registered to ground control points. So to make it happen, first you save session as GCP. Okay. You can also save point cloud. So save all marked scans as global scan. All PC in local coordinate system .las. So it is saved, but I would like to give you one hint, because we would like to combine this data with a point cloud from drone. So we have data from the drone. Okay, and what you have, it is in coordinate system, as you can see, that our data were shifted. Can you see this? So in that sense, we have to take this shift, this one, and we have to apply this shift to our export. So let's back to our export. So where is the... I think I lost my window, so don't worry, just save the session. And let's open the software again, and we open the software because I lost one window. It is a bug, I have to fix it. Don't worry, once you save the session, you can reopen it. So once you open the session, this is session ground control points, you will see that you have everything. You have everything. And what I was looking for is this setting. So please do not close by this. And this is important window because we have offsets here to export. So we apply those offsets. So we have to apply, these offsets. So we have this one, 47710.525. Then we have 552.341.261, and here we have 169.914, and it is done by this, what you can see here. This is this. So once we export, now save all marks scanned as a global scan, all PC global, then we can open in Cloud Compare. So we will open this one from aerial mapping, and we also open data from our system. Apply, but please be careful. We have to choose in Cloud Compare previous input. Yes to all, and I hope it works. Funny thing, it is not working. Give me a second. Okay, let's open again Cloud Compare. And let's observe what we have in global. Maybe I made mistake. So we have input. I will save the input here. This movie is for practitioners, so you will see that you can make plenty of mistakes, but it is most important that in the end of the day you have nice data. Okay, so I have this data, apply. Okay, I have this data. Okay, and then I will load data from Joe. And we have minus 1, 2, 3, 4, 5, 6, 7. Oh, the number of this is not correct. I make mistake by number. I'm so sorry for that. So again, I will try to export. So this number is not correct. 5 5 2 3 3 4 1 dot 2 6 1. Okay, please try to be patient. So I have 477 101. Yeah, it is correct. 552 3341 is correct, and this one is correct. So now I will save all my marks counts as global again. Okay, it is saved. Let's back to Cloud Compare. Let's back to Cloud Compare. Okay, we load from Cloud Compare and we load from our system. And we choose from previous input. And everything is georeferenced with our aerial vehicle. So you can see that we have point cloud from drone, we have point cloud from Mandai system, and everything is well aligned. So thank you very much for watching this movie, and I hope you can replicate results. Thank you for listening. See you soon.